Hi everyone, welcome to the stream. My plan for today is to continue streaming live coding of this library, which is sort of demo. It's a library for handling big integers. So normal integers are limited, and those integers will have arbitrary length. So it's available on my GitHub. Actually, let me show the link. By the way, let me know in chat if I should try synchronization with flubeats because I finally set up NeoVim, and yeah. So if we want to, yeah. So here is the code that I have here. Okay, let me know if I need to try flubeats synchronization. Shouldn't be difficult. So yeah, okay. So there is plus plus, there is plus, there is equals. Let's see if equals work. So let's see if this compiles. Oops. Wow. Oh, okay, it works. Oh, this is interesting. So NeoVim for some reason reacts a bit slower. I don't know why. Anyway, let's see. So yeah, it works. So there is equals. There is constructor from just unsigned integers. Comparisons work. What should we do now? No, wait a second. I need to check chat. No, it says bad. Why? Let me check the quality here. Oh, I think it works. Alright, so I guess I should code a multiplication, and multiplication of big integers shouldn't be that difficult. It's actually fairly, I think it's fairly straightforward. What we do is we create a result integer. We take digits and the size of okay, it should be multiplication, and the size of the resulting integer is this. Okay, so question, what is afferent classes in C++? So normally classes don't have access to private data or private function members, and unless they're declared as friend. So friend classes have access to private stuff. So for example, here I don't have a friend class. I have a friend function, but it's a very similar concept. So here is the output operator, and what it does, it just iterates over digits and outputs every digit, and yeah, then it returns the stream. But the important part is that digits are private. As you can see, they are declared as private. So normal functions can't access digits, but friend function can. So if I remove this, the code will stop compiling. So as you can see, digits is private member of big integers, right? But yeah, if we declare this as friend, it's going to work just fine. Oh, okay, this is warning is because I haven't implemented this function yet. So, so multiplication. All right. Let's actually multiply everything. Size. plus I. Wait a second, it's not rest digit size, it's this digit size. So we iterate over two numbers. We iterate over these digits, and we iterate over other digits. And then, oh, okay, some weirdness with NeoVim. I'm using it for. Hi, what are you trying to do? Okay, so I'm coding a big integer library. Normal integers are just, well, normal integers are not infinite, right? So if you write things like that, okay, I can actually show you a demo. Where is? Okay. Let me show you the demo. Oh, some weirdness in NeoVim, or a combination of NeoVim and Tmax. Okay, so we have the big integer class here, and if you compile this, we can see that x is, well, 1 billion, y is 1 billion. Yes. Then we assign x plus y to the z, and we output z, and it becomes 2 billions. And then we, let's say we create another integer a, and it's z plus x plus y, and it's 4 billion, which is not surprising, of course, but let's say we replace big integers here with normal integers, right? So let's replace this. Yes, this is a perfectly valid code, except that we have an overflow here. So, well, this is actually an undefined behavior in C++, and but yeah, so we have an overflow here because integers are not infinite, unfortunately. So I'm coding a class that, well, sort of acts like an integers. So it has lots of operators overloaded, like plus, and you could use it as a drop-in replacement of integers. Right, so again, if we compile this, it's going to work. Again, yeah. So right now I'm trying to multiply two big integers. So yeah. So we take. So what we do here is we just multiply every digit to every digit. Just like you would. Wait a second. Why is this I? It shouldn't be I because, well, because we get infinite loop here. It should be J. So just multiply every digit to every digit. Oops. And yeah, and then we have a magic function called handle carry. So what I can probably show what I'm doing. So let's say we have 12 and we have 13, or so let's say we are multiplying 12 by 18, right? So what we do is we iterate over one number, we iterate over the other one number, so we get a number that sort of looks like this. 16. I guess. Oh, wait a second. Yeah, I just realized that I coded it wrong. We multiply every digit to every digit, but of course we need to do plus equals. Okay, so here we get 10, and the last digit is 1. Again, so we get 3 digits after executing the code. Right, after executing this code, we get 3 digits. But unfortunately, the problem here is that Hope everything is correct here. Anyway, the problem here is that one of the digits, or two of the digits are sort of overflowed. So what we need to do is we need to take this digit, replace it with 6 and carry over the 1 to here. And then we take look at these digits. We again replace it with 1 and carry over 1 to here. So we get 216, and I hope this is the correct answer. Yes, I still can multiply. Again, we implemented the first step, which is doing this. Yeah, this is true. I mean, I'm assuming you refer to the question. Okay, so we implement the first step here, and we actually have handle carry function here, which iterates over the number and sort of normalizes it. So instead of having this weird number, we get 216. Oh, yes, let's go. So we do res handle carry, and yeah, it works. Sometimes when multiplying by 0, the number will become something like, so I'm going to show a demo. This code contains another problem. So let's say we have a number like 1, 2, 3. We decide that we need to multiply it by 0. So after executing our code, we will get something like 0, 0, 0. So it's a 3-digit number with every digit being 0. And that's not what we want. We need to 1-digit number 0. So we need to call the function that's remove leading zeros. Oops. So remove how to implement it. Let's see. Remove leading zeros. Okay. We take this function and we just simply digits and these digits so we look at the leading 0. So we lead the leading digit. So we look at the leading digit, we compare it to 0, and if it's 0, we just remove it. Should I just do pop back? I hope I still. Oh yes, I hope I still remember C++, but I'm pretty sure there is pop back function. Yes, awesome. Again, and I hope this code works, but let's test it. So let's just take z multiplied by x multiplied by y multiplied by 13. I don't know. Let's see. And it works. Wondering if it works correctly. So no, I have suspicion that it doesn't work correctly. Oh no, yeah, it does. It works correctly. Z is 2 billions and y is 1. X is 1 billion. Y is 1 billion. So let's see. So we take this number. We multiply it by this number, we multiply it by this number, by 13, and yes. So this part works. We have multiplication now. Okay, let's code a plus plus. post increment. And the difference between declaration of post increment and pre increment is that post increment takes a fake integer, and it works differently. It also actually creates a copy. So we return not a reference, we return a copy, and we make big integer copy, right? We create. So we know how ++ works. I'm going to quickly explain this. Let's open our daemon ++. So we have two ++s, ++x, and let's say x is equals to 2. So ++x increments the number and returns the new value. So I hope this makes sense, but this code would print 3. On the other hand, this code would print, well, 2, because post increment does this. It increments the number, but it returns the previous value. So it returns 2. And I hope this makes sense. There is a subtle distinction, but for our class, it's actually going to matter a lot. And yeah, so we make a copy. We increment a copy. We can use a prefix increment here. And then we just return the copy. And as you can get, what the hell? Oh, yeah, let's do this. Let's copy this. Let me check if there are questions. Okay, if you have questions either about my code or about C++ in general, feel free to ask. Okay, so this leads to copying. So generally, this operator shouldn't be used. Again, I'm wondering how long have I been streaming. I plan to make this stream a shortish. Maybe I'll stream for another 20 minutes. Basically, okay, let's implement non-equals. So for example, right now we can do z equals to 42, but this will not compile. We haven't implemented this operator, right? So we have a normal comparison here. Let's take everything. So we have non-equals, and we can actually implement non-equals in terms of equals operator. So we could simply write this, not this equals to other. So this would totally work. So yes, you can see z equals to 0 returns false, and z non-equals to, oh sorry, d equals to 42 returns false, and d non-equals to 42 returns true. Okay, can we actually write things like that? Again, it totally makes sense for our class to have a less than operator. But of course we have to implement it. We have to implement everything, like every operator. So we have equals here. So let's take Still wondering how are you going to do division. I probably will not do division today. I don't think it's super complicated to implement, but it's a bit tricky. I'm wondering why aren't you curious about square root, for example, because implementing square root is definitely more tricky than implementing long division. I mean, implementing long division, again, square root isn't, I think that square root isn't, like, at least naive implementation of square root isn't very difficult to do. Basically, you could do something like this. Let's say you want to, I don't know, extract the square root of this. You could do sort of binary search. So you take something like 77, for example. You well, you, how do I say it? Okay, damn it. Okay, you multiply it by 77. Well, yeah, you could either brute force, but a smarter way is just to do binary search. Then you get that 77 multiplied by 77 is more than our target, and you do a division, and you get something like 36. Multiply again, it's bigger than that, so you do something like this. It's bigger than, so you do something like 9, and then you get this, and this is smaller than that. So you then again do something like this. So pretty much binary search. I don't know if there are more efficient implementations of square root, but this is how I would implement square root of a long number. And implementing division is kind of similar, like you divide numbers on paper. I don't know, I haven't divided it in a while, but in my school we had an algorithm of dividing and two like numbers. So I don't know. I'm actually wondering if other countries use a different algorithm, but it's actually really interesting. Let me check it. I'm just going to use Google Images. That looks similar to what we did. Yeah, this is kind of like what we did in school, I believe. So you could implement without weird arrows, though. So no weird arrows. I don't actually remember how to do this. I mean, I would probably be able to divide two numbers, but it looks somewhat. Damn it! The image is too small. Anyway, we did something like this, and except the result wasn't written here. Anyway, I guess there are some minor differences, and you could implement something like this in your program. That's how I would implement long division. Anyway, square root sounds like fun. I'm going definitely to implement long division and square root, but first let's complete mundane tasks like less than. So let's say we want to less than operator. So we have two big integers. So should we implement less than or more than? I don't know. Let me check chat. Are you C++ expert? I don't know. I mean, depending on what you mean by expert, I definitely wouldn't call myself an expert, but I have quite a lot of knowledge of C++. So, so if you want, you can ask me questions. I wouldn't call myself an expert, though. I know, but I will not deny that I have quite a bit of experience. Yeah, that's how it looks. Math skills. This is something like we did, and the layout looks very familiar. Yeah, this is it. This is what we did in school. So I guess it's it's the same in Belgian schools. Okay, let's go. Let's take this. First, let's compare sizes. Which is going to if this digit size is less than or digit size, we are going to return true, because no matter what, 2 digits number cannot be greater than 3 digits number. On the other hand, it works in the opposite direction. So in the opposite direction it works too. So we compare sizes, and if we can deduct, if we can determine the answer from just sizes alone, we return true or false. And then after that, we have a 2 digits number. After that, we have 2 integers that have the same length. So we are going to iterate over the. Actually, let's do this. Let me check something. Okay, everything works here. Plus I. So we check. So we check the digits. If these digits are less than 4 digits, Y return false. And if it's more, wait a second. Again, if it's less, we return true. And if it's more, we return false. Again, because of the situations like this. So let's say we have a number 98 and we have a number 79. So we compare 9 and 7, and we determine that 90 something is definitely bigger than 70 something. And again, if we never return from this loop, it means that the number are equals. So we return false. If we reach this line, it means that the number are equal. Sound, I don't have sound. Wow, this is bad. Reached this. I have sound. Are you sure it's not a problem on your side? Okay, so we have an operator less than here. Let's actually test it. Okay, z is less than 42. Okay, let's say if z is less than z, it should return false, right? Oh, segmentation fault. This is bad. This shouldn't happen. Okay, let's see what we. Oh, plus plus I. That's why we need minus minus I. So yeah, silly mistake. Okay, it works. Let's say if z is less than z plus z. Okay, again it works. Can we write this? And we can't really write this again because we haven't implemented this operator. Normally, when you have comparison operators, one comparison operator, you implement another one. Luckily, so it's kind of annoying, and we need to implement. Okay, let me test my own stream. Kind of annoying, and we need to implement. Okay, I think it works fine for me. I don't know. Hopefully it's just your internet connection, but if it could be mine though. Let me check OBS settings. Fine. Okay. Okay. Can someone else confirm this problem? Okay. So we have, and I'm going to continue. Okay. So we have this operator, and we want to implement more than. Oh, great. So we need to implement more than. Luckily, we can use the same. And it's annoying because we have four operators: less, more. I mean less than, greater than, less than or equals, and greater than or equals. So we have four operators, and well, of course, we have also equals and non-equals. So we have 6 operators actually, which is super annoying to implement, but luckily we can just write a bit of boilerplate code. So we can just write return or less than this, and or isn't equal to this. Oh, thank you very much. I guess it's the problem on your side. Oh, wait a second, and I forgot const. Yeah, of course I should have used const here. So we use const for methods that don't modify the state of this. Okay, the reason for using this weird notation. Yes, there is a reason. Let me find this weirdness. It surely look weird. Okay, the reason why I am using this, and the reason is that we have to implement every operator for our big integers because C++ doesn't know how those operators should work for our class, right? Because, well, it's a special class, it's a custom class, and C++ doesn't know anything about it. So we are telling C++, here's how equals work, right? So we just compare sizes of these numbers, iterate over the digits, and well, make sure they're equals. And if they're equals, just return true. Here we are implementing non-equals operator. So I actually don't know if you can write this, but let's say I'm actually curious. So this either will not compile or this will be an infinite loop. Let's just see. Okay, surprisingly, So finally this compiles. Okay. I'm going to show you. This is going to be an infinite recursion, an infinite loop, right? So segmentation fault. Actually, yeah, okay, this would make sense because where is it? Where is the code? Where is the code? Okay, so because this line actually calls this operator. So this line calls this method, and yeah, that's why we shouldn't do this. That's why we should use a weird looking thing. Okay, great. Totally ask me questions. I'm always happy to explain what I'm doing and explain the C++ concept. So again, we are using similar tricks for implementing more than, operator, more than, right? Greater than. So we compare. Oh, I'm writing too much Python. If you don't know, C++ has AND, but this is not really idiomatic. I should write this. Both lines will compile. So if you don't believe me, I'm going to show you. Not every C++ programmer knows this, but this and this means the same thing, right? So both compile just fine. Anyway, you should write ampersand instead of just n. And I have been writing too much Python lately. Okay, so we implement operator greater than in terms of less than. Yeah. In a similar fashion, we can just implement operator greater than equals, right? So we just return if other is less than this. And we also need less than equals. I mean less than or equals. And to do this, we return this, or so it's either, wait a second, that's not correct, that's not right. And it's the same thing, but I like this formatting more. So let's move the arguments. Okay, so what do we have every operator? So we have less than or equals. We have greater than or equals to, which is great. We can now write things like z is more than equal to c plus d. Totally works. Or c plus dz more than equals to c plus d, and it doesn't work. Wait a second, does it? Test. Wow, it doesn't work. Okay, let's debug it. Let's see what's going on here. Oh, wait a second. Of course, I should compare. Oh, yeah. I don't know why. I remove this line. Yes, now it works. Again, we can add +1 here, and it's going to totally work. Yes. Again, let's add +2 here, and this should change to 0, right? Yes. So it works. I definitely need to write a set of tests for this class, but I guess I will do it during the next stream. So let's see what we have now. Oh, we have plus, two plus pluses. We have plus, we have addition, multiplication, comparison. So yeah. What else? Okay. Oh, yeah, sorry. I should have paid attention to this chat. I guess I fixed this mistake. Hopefully. Okay, let's see. This should change to 1, and it works. Again, this should change to 1. So, I mean, it shouldn't change. It should stay 1. What's next? I don't know. You are doing if less than or equals. Oh. I mean, this doesn't make sense, actually. But I don't see the issue here. So less than or equals is, well, less than shouldn't be in more than equals. Okay. So more than or equals. I mean, I don't know what's the proper name. I think it's greater than or equals. So we have this operator. So first we check if this is greater than we check if this is greater than other, and if it is, we return true. You are doing less, which is I mean, I'm definitely executing this operator, but I'm swapping the arguments. So basically, this is called like this. So this is essentially this operator dammit near vim. So I'm calling this, and which is the same thing actually as this. Actually, you know what? And well, as you can see, you know what? I'm going to just replace this whole line with it's a correct line, because this thing is the same thing as this thing, which in turn is the same thing as right? So it's, and this is what I wrote, but actually I'm going to replace this with something different. I'm just going to write this, I mean, or less than equals than this. This should totally work, right? When will this source will be available online? Yes, totally will. It's actually already available. I mean, part of this uh, library is already available. I'm going to push the code to GitHub right now. Oh, wait a second. I shouldn't remove this. Yes. Okay, let's see. So, multiplication, comparison operators, x plus plus. What else? Yes. Okay. So the source will be available online like right now. Here is the link. If you are curious, you can look at it. Here is the exact link to the file. Feel free to use it. I actually added a license here, which is just MIT license. So yeah, this is it. Okay, I'm going to end the stream now, but if you have questions, you have a chance to ask them. And if there are no questions, I will end the stream. Totally ask me questions. I will be happy to answer them. And I hope I addressed this issue. Basically, I just had to swap arguments. Okay, I don't know if it makes sense. Okay, so I'm keeping an eye to chats. Totally ask me questions. I'm going to wait for like 1 or 2 minutes. So I'm going to wait for 2 minutes, let's say. And then I'm ending the stream. Totally ask me questions if you have any. So meanwhile, I'm going to talk a bit about the next. Thank you. I'm glad that you enjoyed it. So the next time I'm going to probably implement the long division. So long division tests and possibly negative numbers. It's actually going to be interesting. So it's going to be either long division or negative numbers. Probably long division though. Handling negative numbers is actually not difficult. What you need to do is you need to store a sign bit. So you store a sign bit. And yeah, so you have the sign bit, and according to it, you just implement everything. I mean, essentially handling negative numbers boils down to this thing. You just have a number. So we have almost everything implemented for positive numbers. And let's say we want to do also I plan to do benchmark. This would be fun. Assume if I stream this, this would totally be fun. So probably yes. So as for negative numbers, we just noticed that, for example, minus 123 is the same thing as minus 1 multiplied by 123. And for example, multiplying negative numbers is the same thing as multiplying their sign bits. And yeah, do normal positive numbers multiplication, normal multiplication of positive numbers. So I hope this makes sense. Just a quick question regarding the line 56. Sure. Line 56. Let's go there. Okay. Line 56. I less than I less digit size plus I. Okay, I'm waiting for the question. We want this start the iteration on element number 1 rather than number 0, allowing for comparison of two objects. No, not really. I can probably demonstrate this. Okay, so we have big integer x, big integer y. Oh, specifically regarding the use of. Okay, I can explain this. What you can do is first let me show you a quick demonstration here. We remove everything, and we add here okay. So it starts comparing from index 0. So first of all, it works correctly. About like meaningful part of my answer, and it's that the for loop works like this. It increments. I mean, it executes this part of loop after each iteration. So not before iteration, but after. So it works like this. I can just simply move this part over here. And it's going to be essentially the same thing, right? It doesn't change anything. And I can actually move this part over here. Oops. Damn it. Again, it's the same thing. And I can actually remove even this part. So I can move it here. Or actually, I totally can move it, but at this stage, I would rather replace for with while. What the hell? Stop doing this now, Vim. Okay. So I just refactored the for loop into a while loop, and it's the same loop. So for loop. So if you remember the loop I had, now I have a totally different loop. I mean, a different type of loop, but it works exactly the same. So first, this executed only once, and this executed on each step, and the third part of the loop is executed only after the end of iteration. So I hope this makes sense. Like, I hope it answered your question. So essentially, this is executed after each iteration, and the result doesn't really matter. I mean, the result of this expression. Oh, I don't know about PHP, so maybe a PHP would work in a different fashion. So if there are other questions, I will be happy to answer them. As I mentioned, I can stay for quite a lot of time if you have questions, of course. Um, so, okay, yeah, probably. Okay. Okay, if you or any other person have a question, just ask me. Meanwhile, I'm just going to talk a bit about the code. So next time I will probably handle long division, and then I move to negative numbers, and then I will move to, I don't know, probably benchmarking. It's actually going to be fun. Ever had aspirations to be a teacher? Well, maybe. I mean, I'm trying to teach something right now, so hopefully you are learning something. I don't know. What should I talk about now? I mean, I'm just waiting for questions. I thought, oh, by the way, yes, another thing that I definitely need to implement is proper testing framework or just proper unit tests. Oh, okay, no questions, I guess. So, okay, one last chance to ask you a question. I'm waiting for 30 seconds. Talk about Ellen. I'm surprised, but Ellen Pao is no longer the CEO of Reddit. I don't know. Apparently, Redditors hated it so much that she had to step down. Well, that's my interpretation. But personally, I have nothing against Ellen Pao. I don't know what she does. So I don't know if she was a good CEO of Reddit and I don't know if she was a bad CEO of Reddit. So I don't know. I mean, I guess that's up to Reddit shareholders. So I actually have no emotions about that. I mean, I never really hated her, but they definitely handled that situation about Victoria. So they definitely handled that situation poorly. Well, I don't own Reddit stock, so I don't own any Reddit shares. Anyway, I definitely think that they handled the Fight People Hate drama and Victoria drama very badly. They definitely communicated poorly, so I think the mods has right to be mad at Reddit admins. But I don't think that Ellen deserves personalized hate like some editors wish her death, which is insane. I mean, she's just a CEO of Reddit. Anyway, maybe it's good for Reddit, maybe it's bad for Reddit. I guess it's not. I guess the new CEO is Steve, who is one of the original founders of Reddit, so it's probably good for Reddit. Anyway, I'm talking about completely off topic and my just counter on Twitch crew. Anyway, I'm ending the stream now. Thank you very much for watching. It was a fun stream. I will definitely stream more of this stuff probably tomorrow, but I'm not sure. So yes, later.